The Science of Meditation. Chapter 13. Research on Meditation. After sharing the initial draft of this book with some of my readers, I received a long reply from Dr. Heather Redd, a professor of psychology at the University of Connecticut. In her reply, Dr. Redd provided a comprehensive summary of the latest research findings that she had gathered related to the connection between meditation and sleep. However, Dr. Redd noted that there are presently very few clinical trials about that subject, which is precisely why researchers in biology and psychology should investigate it. But before we delve deeper into this topic, let me first familiarize the reader with one of the most commonly used concepts and tools in neuroscientific experiments, the electroencephalogram, or EEG for short. An EEG is an electrophysiological monitoring method used to record brainwave activities, which are the electrical signals generated by the brain's approximately 100 billion neurons. To detect brainwaves, electrodes are placed on a person's scalp to pick up the brainwave signals, and a computer collects and processes the EEG data. Research has shown that the majority of rhythmic brainwave frequencies fall within a range of 1 to 30 cycles per second, or 1 to 30 Hz. Within that frequency range, brainwaves can be roughly divided into four essential kinds, from the slowest to the fastest: delta, less than 4 Hz, theta, 4 to 8 Hz, alpha, 8 to 12 Hz, and beta, 12 to 30 Hz. Brainwave frequencies change during sleep, following a specific pattern that divides sleep into several stages: N1, N2, N3, and REM, which stands for rapid eye movement. During REM sleep, one's eyes move around rapidly in a range of directions, but do not send any visual information to the brain. That doesn't happen during non-REM sleep, which includes stages N1 to N3. The N1 stage, which is the onset of sleep, is characterized by alpha brainwaves. The N2 stage, or light sleep, is dominated by theta brainwaves. The N3 stage, or deep sleep, is dominated by slow delta brainwaves. And REM is dominated by beta and even higher frequency brainwaves. The brain activity measured with EEG typically follows a cyclic pattern, with the first cycle transitioning from wake to sleep and including sleep states: wake, N1, N2, N3, N2, REM. Following the first bout of REM, there are multiple cycles that include N2, N3, N2, REM throughout the night until one wakes. Each sequence of brain activity changes transitioning from N2, N3, N2, to REM is referred to as one sleep cycle. An average human sleep cycle lasts about 90 minutes, so a typical night consists of 4 to 5 sleep cycles. Notably, during N3 or deep sleep, it is harder to wake people up if they are in this phase. Muscle tone, pulse, and breathing rate decrease during N3 sleep as the body relaxes even further. The brain activity during this period has the slowest delta waves. For that reason, N3 may also be called delta sleep, or slow wave sleep. Scientists believe that this stage is critical to restorative sleep, allowing for bodily recovery and growth. It may also bolster the immune system and other key bodily processes. Although brain activity is reduced during this stage, there is evidence that deep sleep contributes to insightful thinking, creativity, and memory. Dentico et al. Discovered that immediately after 8 hours of intense meditation, long-term meditators exhibited significant reduction in delta brainwaves within the first 90-minute sleep cycle, compared to meditation-naive participants, i.e., individuals with little or no experience with meditation. That finding closely resembles the data presented by Dirk-Jan Dijk, which suggests that, after a daytime nap, there is a significant decrease in delta brainwaves during the following nighttime sleep, which the author calls a homeostatic phenomenon. Homeostasis is a self-regulating dynamic equilibrium process by which biological systems maintain stability while adapting to changing external conditions to support normal life processes. In other words, during daytime naps, individuals have already generated a considerable amount of delta brainwaves, so they don't need as much slow-wave sleep during the night. According to Dentico et al., meditation has a similar effect, meaning that, after meditation, individuals require less slow-wave sleep at night, which demonstrates that meditation and napping are very similar in terms of brainwave generation. Furthermore, after meditation, not only is there a reduced need for slow-wave sleep, but the overall sleep duration is also significantly decreased. Call et al. Presented detailed data which demonstrated that meditation acutely improves psychomotor vigilance and decreases the need for sleep. That finding is strikingly similar to the data presented by Dyke, which demonstrated that, after a daytime nap, slow-wave sleep and overall sleep duration both decrease, which the author explains as homeostasis, as discussed earlier. Dentico et al. Discovered that the brainwave activity of both long-term meditators and meditation-naive participants during meditation was not dependent on whether their eyes were open or closed during meditation. Nor did their brainwave activity correlate with the specific meditation techniques they used. These results align with many viewpoints already presented in this book. For example, in Chapter 9, The Ultimate Method, I pointed out that one can enter meditation solely by keeping the body still, and that the various elaborate meditation methods, such as observing one's breath, are unnecessary. The only purpose of those methods is to help meditators to maintain bodily stillness, which will eventually trick their unconscious brains into believing that they have fallen asleep. In Chapter 5, Sleep Ability, I also pointed out that whether one's eyes should be open or closed during meditation, or half open and half closed, is her or his call, but makes no difference. Although the studies discussed so far have revealed some physiological similarities between meditation and sleep, there are also clear differences between them. One distinction is that individuals can meditate while lying down, sitting, standing, or even moving, whereas people usually sleep only in a lying down position. Of course, the most significant difference is that during meditation they maintain consciousness, whereas during sleep they lose consciousness. However, there are specific situations, known as lucid dreaming, in which individuals can be aware of their dreams while they are dreaming. But lucid dreaming should not be confused with daydreaming, during which individuals enter a fantasy world while awake, whereas lucid dreaming occurs when individuals maintain awareness while asleep. During lucid dreaming, individuals have the ability to think and remember as they would when awake. Some individuals can even make their dream experiences feel as real as waking life, but still remain aware that they are dreaming. Baird, Tononi, and LaBerge discovered that lucid dreaming occurs during REM sleep, and is not simply a mixture of sleep and wakefulness. Thus, meditation and lucid dreams work in opposite ways. During lucid dreams, individuals are initially asleep, both in body and mind, as they dream, but then wake up consciously during their dreams, while their bodies are still sleeping. In meditation, on the other hand, individuals are always mentally awake, while letting their bodies sleep. In other words, lucid dreaming and meditating are almost identical in their final phase, with the mind awake and the body asleep. In fact, Nagendra, Maruthai, and Cuddy, who conducted an extensive study of research papers on meditation and its regulatory role on sleep, arrived at the following conclusion. It is evident from the literature cited that practice of meditation brings about global changes. Many of these alterations in physiological functions have great similarities to the changes that are happening during sleep. It has been proposed that sleep is an autoregulatory global phenomenon. It is also true that meditation influences sleep and its functions. It appears that various components of sleep-generating mechanisms can be altered with meditation. Meditation, with its global effects on body and brain functions, helps to establish a body and mind harmony. Thus meditation practices as an autoregulatory integrated global phenomenon, opens a wider scope for understanding the unique aspects of human sleep and consciousness. As you can see, this conclusion closely aligns with the concepts I have presented in this book. The only distinction lies in the additional step I have taken by asserting that meditation is sleep. Or more precisely, it is awake sleep. It is sleeping with consciousness. Modern studies that suggest a commonality between meditation and sleep continue to unravel the greatest mystery of human nature, the interplay between mind and body, as well as the boundary between illusion and reality. But the truth may not be as complicated as some people think, because meditation and sleep could be the same thing, or just two sides of the same coin, making their similarity one of the most intriguing scientific topics of the 21st century.